An object is moving in a circle of radius 150 cm and at a speed of 17 cm per second. At the 4th second, calculate distance covered, angle squared by the object, angular velocity of the object. Okay, so let's try to bring out all our parameters. Alright, so there you have it. Now let's say distance covered, and we know that distance s is equals to let's do ut plus half at squared. But we notice that distance also rise when we are given this, but we know that from v equals to s over t, that this can be the same thing as saying s equals to ut. So I can just say s to be equals to 0.17 times 4. So now 0.17 times 4, which is 0.68 meter. That's my distance. Then they said angle squared by the object. So angle squared by the object is talking about theta. True? Yes. Yes. Angle squared by the object. So I know that I have, let me do something. Let's say I do, first of all, v equals to u plus et. Okay. So that I have this to be 1.5, sorry, this to be 0.17 plus, but I don't have e. Okay, I can actually say, s. There's an equation which gives us that s is equals to theta r. So I can actually say theta is equals to s over r. Since I have distance and I have r, I can actually say 0.68 all over 1.5. So one of the things that happen with this physics is that, especially circular motion physics, is that there are so many formulas that can give you the same answer or even different answers. But one of the things that happen with this circular motion is that it's not something that you are fixed about. You have to be very careful, and then when you are trying to get your answer, you try to remember all the equations, and when you do it for long, you become part of it. So this is for B, this is for A, Now, next one is angular velocity of the object. Angular velocity of the object. And the angular velocity, angular omega w, is equals to theta over t. Yes. I don't have e, that's the reason. I could have used w equals to wo plus at, but notice that I don't have e, but I have o, which is 1.5. Oh, sorry, 0.17. Yes. I don't have e, so that's why I'm using this. So I can say this is w equals to 0.5 all over 4. So I have 0.5 divided by 4, which is giving me 0.125. and since it's angular velocity, I have rats per second. I think in order to be able to get your answer and be sure, is simply always making sure that when they talk about the angular or whatever, you are making sure that whatever you're using is something that will give you radians per second. For example, this is theta, rats, radians, this is second. Just like the one we did in class. Assuming they ask me centripetal acceleration, I will always use those things that when I compare it, like that's A equals to V over R, because centripetal acceleration is in meter per second. So I always use those units that run through kinematics. So there you have it. So we've been able to find the angular velocity yes, and the rest. So let's try to use equation of motion here. The angular velocity of a body is initially 14 revolutions per minute, and its angular acceleration is constant and equal to 22 revolutions per second square. A particle in the body is horizontal at time t equals to 0. Calculate the angle the particle will make with the horizontal after 5 seconds. Find also the angular velocity at this time. Let's bring out our parameters. So there you have it. So from that, I've been able to get out all my parameters. So the next thing is to convert revolution per minute to radians per second. So I'll do one revolution. Sorry, I'll do one revolution. I put revolution where it can cancel revolution is equals to 2 pi. Then 1 minute, I put minutes where it can cancel minutes is equals to 60 seconds. So minutes cancel minutes, revolution cancel revolution. So 2 here 7, 2 here 30. So I'm having 14 pi. I'm having 14 pi over 30 seconds. That's something. Okay, so if I do 14 divided by 30, 14 divided by 30, I'm going to have 0.4667 pi per second. That is pi, yes, pi radians per second. I don't want to convert the pi for now. Then for 22 revolution per second, I do times 2 pi over 1 rev. This will cancel this, so that I have 44 pi per second. So okay, so if I wanted, I can do 22 over 7 times that. So but I just want to be carrying the pi along. So now they said I should get theta, so I can actually say S, let me check, equals to, or you say theta is equals to WOT plus half, since I have acceleration, yes, I have initial, so half acceleration times t square. That is from the equation of motion, which is ut plus half at square. So let me put this. Initial velocity is 0.466. Okay, let me just do this now. 667 times, yes, 22 over 7. So plus half 44 times 22 over 7. Then t at that time, that is time of 5 seconds square. So let's do this. Let's punch this now. We now have 0. Okay, first of all, let me do 22 divided by 7. 0.143. 3.1429. Okay, 2929. So 138.2876, then times 5 square, which is 25. So let's do this now. You now have 138. Okay, let me do it. So there you have it. So theta is equals to 2 times 1.4668, which is 2.9336 plus 3457.19 divided by 2. So if you divide this by, so if you do 3, if you divide this by 2, our theta is going to be 1730.1, and that's in radians, rats. So that's a very big one, rats or radians. Alright, so the next thing they asked us to find is the angular velocity at that time. The angular velocity, because notice that what we have is initial velocity. So to find this, we simply say W equals to W naught plus acceleration times t, that is from v equals to u plus at. So this is going to be W naught equals to, so I have everything here for this. Okay, yes, this one gave me initial as 0.46667 pi. Then plus a is 44 pi. Sorry, this should be second square. So second square, then times time. They said at that time, so 5. Remember the question. So if I do this now, I'll get my W. And then notice that as I'm going on with this, I notice that what I did here is W naught, which is 0.4 pi, then the t here, which is 5, we did not include it, times 5. Sorry, we did not include this 5. So it's supposed to be everything we had here, times 5. So this is supposed to be times 5 in the first place, before even doing the 2. So let's do it. So what I'm supposed to have here is 7.334. That's what I'm supposed to have here. 7.334. So 2 times 7.334, that's what I'm supposed to have here, which is going to be 14.668. That's what I'm supposed to have. So by the time you add it up, let me add it up. So up here I'm supposed to have 3471.858. So divided by 2. So 3471.858 divided by 2. So I have 1735.9 radians. Alright, so thank you. So let's go back. W equals to, so this is going to give me 1.46668 plus, when I did this one, we got 13. Yes, so when I do this now, let's do 138.2876 times 5. We use the very large value. So you have, if you times it by 5, you have 691.438 plus 1.4668. So plus 1.4668. So you have W to be equals to 692.9048. So W is approximately 693. So, and this is going to be in rads per second. That is it. So this one now, you are doing this one for me. This one, you are the one doing this one for me. This one, the turntable of radio 12 cm rotates with angular acceleration of 3 rads at the end of 2 seconds calculates. Remember that when we hear acceleration without mentioning velocity, that means that it has an initial velocity which is 0. This question has an initial velocity which is 0. So do that one for me. Now let's quickly rush to this one. Okay. So the answer to this question is circular motion. Angular motion, anything that rotates, is not must it completes the whole quadrant, it's angular motion. But for circular motion, you must go through x, y, negative x and negative y. Now they said moment of inertia of a rigid body system is twice as great about an axis through an end as it is about axis through the center. Yes. What it means is that when it's at the end, it means that the orientation, its rotation or its distribution, mass distribution, is everywhere. So it has more mass of inertia. It's even harder for it to, or should I say, rotate when it is at that end compared to when it's at the center. That is one. And even when it starts rotating, because it's at the end, it will have more movement or more spread. Okay, that's the part, my own contribution to that. Then this part where they say we should solve this.